Hello friends, welcome to engineering tutorial. So this is the sixth question that we are going to discuss on superposition theorem. So this is the circuit. It consists of three sources, two independent current sources, 120 ampere, 40 ampere and one DC voltage source, independent 10 volt. And we have to find this current I. And please note the direction of the current is from right to left. Okay, just to get an idea, because it is very important. Okay, that is the reference. So we have to determine the value of I. So we will do it using superposition theorem. We will do it in 3 steps, considering 120 ampere, 40 ampere and 10 volt separately. Okay, so let us first consider the 40 ampere current source. We will open circuit 120 ampere, short circuit 10 volt. Okay, so we are open circuiting this. This is 50 ohm. This is short circuited. This is 150 ohm. This is 40 ampere. 50 ohm, 150 ohm. Let us call this current as I dash. So this is a 2 resistor form. We can apply current division rule here. So I dash, we can calculate it as 40 into, okay, the other resistor, which is 150. We have to find this current flowing through 50 ohm. So we will multiply it with the other resistor, which is 150, divided by the sum, which is 50 plus 150, which is 200. Okay. So it is 30 ampere. This I dash value is 30 ampere and it is from right to left. Okay, in this direction it is the same as this reference direction, same. Okay, so step 1, the current, because of the 40 ampere current source, is 30 ampere. Okay, step 1. Now we will consider the 120 ampere current source in step 2. Okay, so let us do that. So this is step 2, in which we will consider 120 ampere current source. We will short circuit the 10 volt voltage source, open circuit the 40 ampere current source. So let us do that. 120 ampere. This is 50 ohms. This is short circuited. This is 50 ohm. And this is 150 ohms. Okay. And this is open circuited. Now here the current will flow in this way, because the 120 ampere is downwards, so it will be like this. Let us call it as I double dash. So again we have to apply current division rule here, because the 50 ampere, 50 ohm and 150 ohm, they are in 2 resistor form. So I double dash, if we apply current division rule here, it will be 120 into 50. We want to determine I dash double dash flowing through 150 ohms, so we will multiply it with the other resistance. The sum of the two resistance, okay, which is 200. 6. This is also coming 30 ampere, but here the direction is from left to right. Okay, I dash was 30 ampere right to left. Here it is 30 ampere, magnitude is same but direction is opposite. Okay, so this is because of 120 ampere, the current flowing through this branch. This is 30 ampere left to right. So now we will consider only the 10 volt voltage source, open circuiting both 120 ampere and 40 ampere current sources. So now we will move to step 3, in which we will consider only the 10 volt voltage source while we open circuit the two current sources. So it will be 50 ohm, 150 ohm. These two current sources are open circuited. So 50 ohm and 150 ohm. Okay, now the current will start from this, let's call it I triple dash, okay, and it will flow in this way, and no current will flow through these two open circuited terminals. So this current I triple dash will be voltage divided by resistance, which is 10 volt divided by the total resistance, which is 200 ohms. So it will be 0.05 ampere. Okay, 0.05 ampere. Okay, and the direction is from right to left. Okay, so here we have the three currents, ampere, right to left. So the total current I will be I dash minus I double dash plus I triple dash. Why? See, the reference direction was from right to left here. In the question it is mentioned. I dash, it was 30 ampere from right to left, same as the reference direction. I double dash, it was 30 ampere from left to right in the opposite direction. So they cancel each other out, 30 ampere minus 30 ampere. Remaining this I triple dash, it is right to left 0.05 ampere, it is the same as the reference direction. See, these two are same. So it will be plus 0.05 ampere. So the current I flowing through this is equal to 0.05 ampere. Okay, this is. So that's why I always say that the direction of the current which is given in the question, it is very important. All the calculations, all the whatever you do, it will be with reference to that. Okay, and always also pay attention to the polarity of the voltage. Okay, the voltage source or the voltage drop across the circuit elements, so always pay attention to that. Okay, so this is the sixth question on superposition theorem that we have discussed. This is also a bit different. It involved two current sources, one voltage source. Previously we discussed two voltage sources and a single current source. So we have discussed around all types of questions that we can have on superposition theorem. Okay, different types, different patterns. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.